Hello everyone, I'm back with the lab 3 second main circuit, which is the quadrature. This circuit is a little bit more complicated than the previous one, which was VCO, just because of the fact that everything is not shown in this one circuit. To connect it properly, you need to know how to implement the mixer, and then you need to know how to use the op-amp as well. So I'll just try to explain it in this one video, so it's a lot more simpler. So for the quadrature, what we're gonna need here is two 100 picofarad capacitors, one 10 nanofarad capacitor, 0.1 microfarad capacitor. For the inductors, we will be needing 11.5 millihenry, but we do not have 11.5 millihenry as usual. We have to work the way around. So we're gonna be using the parts that are available in the lab. So we'll be using one 10 millihenry and one 1 millihenry, which is gonna make 11 millihenry, and we're still gonna need 0.5 millihenry. So we can actually put two 1 millihenry inductors in parallel to make 0.5 millihenry. That is gonna give us 11.5 millihenry. For the resistor, we are using 2000 ohms, 3.3 kilo ohms, and 18 kilo ohms. We're not using any transistors, so no drain, source, and gate. The other thing we're using is op-amp, which is LM741, and that op-amp is actually this right here. The second chip we are using is a mixer. It's AD633. This mixer is actually right here. What this mixer does is it multiplies two signals and gives one output. One more thing before, just a tip, or maybe a reminder before I start. Let me zoom in. This is how the chip looks like, and you will be seeing a small circle on the top left corner. That means that your device goes up like this. You'll either have a circle right here or half circle on the top. That means that the top side of your device. So how this is numbered is it starts from that side, the top corner left, and it is numbered as 1, 2, 3, 4, and then it comes to here 5, 6, 7, and 8. These numbers are very important because you're gonna know uh, how to count these on these chips to connect them properly. To start with, again, what I'm gonna do is I'm gonna divide this circuit again, as it's a lot easier to divide it and build it. What I'm gonna do is I'm gonna divide this circuit right here to the left side, uh, this, and then on the right side, this circuit right here. Again, we can literally build this like this, and we're gonna be using these wires in the lab anyways. Um, just a tip, um, for future projects, this kit is very helpful. These are literally wires, same wires, but they look a lot nicer and cleaner, and then you can diagnose the problem very easily with those wires. They're very cheap. They're like $5 for the whole box. Just a recommendation if you wanna, if you guys wanna get those wires. So I'm gonna start off again with half of the circuit and build onto it. So on the left side, um, let me, even before starting that, let me tell you guys something. Um, as I mentioned in my previous video that I'm using these two, this bar and this bar right here. I will be using the blue one again for common ground for everything, like a ground for this, a ground for this, this ground, like all the grounds I will be using in the circuit, I'll be using this blue one. It will reduce the wires a lot and makes your circuit a lot more efficient. One more thing, on the top bar of this circuit, I will be using plus 15 and minus 15 voltages. So the positive is gonna be plus 15 and the negative is gonna be negative 15. The reason why I'm doing this is because we need to power this mixer right here and this op-amp with positive 15 and negative 15. So it will be a lot easier if you just give positive 15 into this red line and negative 15 into this red line, and you can use it um, to power any chips, any number of chips. So now I'm starting with the left side of the circuit. Here we have V1, and this is where the V1 is gonna be at. Again, I did not just put the wire here for simplicity. I would be connecting this with the voltage, and the positive terminal, the negative terminal would be going to the ground, the common ground. Um, so I'm just gonna take these out so you can see the circuit better. So again, this is V1, this is V1 right here. This V1 is going into the capacitor. This V1 goes into the capacitor right here. And this capacitor is gonna be connecting with this resistor, which is 2000 or 2 kilo ohms. And this resistor is then grounded. So that's what's happening here. This resistor is then going to the common ground. We also have a capacitor and inductor connected similarly. So what's happening here is this resistor is also connecting, this wire is actually connecting this capacitor right here. This capacitor right here. And this capacitor is now grounded as well. Now remember that I mentioned before that we do not have 11.5 millihenry. So we'll be using 10 millihenry, 1 millihenry and 2 millihenries in parallel to get 11.5 millihenry. So this is the 10 millihenry inductor we have, and I'm connecting this with 1 millihenry and two 1 millihenries in parallel to make 11.5 millihenry. So this whole thing is this is 11.5 millihenry. So see again that this terminal of the inductor is also connected here, and then it is going to ground. So that's what's happening here. This terminal is again connected with this inductor, 11.5 millihenry, and this is also going to ground. Now since we are up to here, now this is our V2. This V2 and V1 will be going into the mixer. This V2 is the output of all this what we just made right here. So this is V2. This will be going into mixer. This is V2. And you can see that V1 is not connected with anything. It's just a wire that is also going to the mixer. So this V1 is just a wire. This is a second input for this mixer. Now we are on to this mixer. The diagram for to use this mixer is not given here, but it is actually given in the last of this lab, which is this right here. This is how you would use a mixer. This is the V1, that's this right here, and V2 right here is this V2. One of the things that I like to do is do the simplest things in the circuit and just get done with them. For example, if you look at this chip right here, this is the mixer. This is right here, and again it is called AD633. And if you look here, number 2, number 4, and number 6, they are all connected and they're grounded. So I would literally do the same thing and get rid of all these wirings. So what I'm going to do here in this chip is remember, this is number 1, number 2. Number 2 is this, it is connected with this wire, and this is then grounded, going to common ground. And then what else we had was number 4 and number 6. Coming back here, 1, 2, 3, and 4. This is number 4 going there, right there, into this ground again. Number 4. And number 6. Number 6 is right here. So we can literally just use a wire and connect them right here. So that is done. Now next thing is giving this device V1 and V2, which is right here, V1 and V2. Remember, this was our V1 from the first part of the circuit, and this is V2. Let me zoom in. This is V2 and this is V1. So V1 is actually going into the number 1 of that chip. So V1 is connecting to this wire and it is going to number 1, and V2 is going into number 4 of the chip. So this white wire is V2, it is going into the 4th terminal of the chip. So we're done with giving V1, V2, and we already grounded this. Now the only thing left is the output and powering this device. We have to power, you pretty much have to power all these kind of chips. They're not gonna work like that. You have to power them somehow. So this plus and negative 15 is powering this chip. So if you look at the powering, the number 8 is going to positive 15. So you come here and you see which one is number 8. Going like 1, 2, 3, 4, 5, 6, 7, and 8. This is number 8. I haven't powered it yet. For the same reason I mentioned before, that I wanted to make it simple. So this is going all I did is connected number 8 to the positive 15. Remember I said that I will be giving positive 15 here and negative 15 here. So this is going to the positive 15. Now I'll get another wire and see negative 15 is gonna go to number 5. So I'll come here and see which terminal is number 5. This is number 5. So I'll just connect this, and I'll connect the other part of it anywhere on the blue side of it, because this is negative 15 and this is positive 15. So we powered the chip, and the only thing left now is just output, which is number 7. Number 7 is the output. This is number 7. This wire is going to be coming out of number 7. I'm going to again take this off. So number 7 is the output, and it is going to the 3.3 kilo ohm resistor. So this is number 7 right here. Rather than having another wire, I just connected the 3.3 kilo ohm resistor right here, and then this is gonna go to the next part of our circuit. Now again, op-amp circuit, how to properly use op-amp is not given here. you will have to go to page number 6 uh, of the lab manual. um, One just quick thing that there is a capacitor right here used between positive and negative 15. You don't really have to use this capacitor because the power supplies we are using are very good power supplies and they're very accurate. um, this capacitor is for less accurate power supply, or if you doubt your power supply, you don't really have to use this. This is just an extra step, and I have tested this circuit without this capacitor, so you don't have to worry about this. Now again, you're gonna see this diagram. It has all these numbers. These numbers are corresponding to what I told earlier, that this is how the chips are numbered, and these numbers tells you what goes where. um, Again, we're gonna come to this op-amp, and one of the simplest way is to start with the very simple thing. um, Power this, which is going positive 15 is going to number 7, so we'll come back to this. So positive 15 is going to be this. We are going this to number 6. Number 6 is right here. I haven't connected the wire, but I will connect it right now to show you guys. Number 6 will be connecting to 15, just like that. And then if you come back, you will see number 4 is connected to negative 15. And then number 4 is 1, 2, 3, 4. So this was just right there, so I used a small wire to connect it to negative 15. Let's just take this off, it makes issues with the camera focus. Now you'll come back here and see that positive is number 3, and then you come back here in your main circuit, and you see the positive is just grounded. That's simple enough. So remember, the positive was number 3, 1, 2, and 3. 1, 2, and 3. This is going to this wire, and this is grounded, the common ground. Now, the inverting input of this op-amp is number 2. What it means is the negative, what you see here, is inverting input. What we are getting from the resistor needs to be connected with this side, which is number 2. Number 2. So this resistor, we are connecting this part of the circuit with this part now. So this resistor is going here, and this wire is going to number 2, which is right here, number 2. So we connected the previous wire with this part. Now you see the output of this op-amp is connected with one resistor and one capacitor. We're gonna do that right now. First we have to come back and see what is the output of op-amp. The output is number 6. So we come back here and we count where the number 6 is. 6 falls here. So this is connected with one resistor, which is 18K, and it is also connected with one capacitor, which is 10 nanofarad, and both of these are connected back to the inverting input. Come here and see what was inverting input, number 2. So this is gonna come back and connect to number 2, and this circuit is almost complete. One more thing, where you need to connect the oscilloscope. Remember, connecting oscilloscope is gonna be the output of op-amp. Where this sign is, that means you need to connect the oscilloscope. So come back and see what the output is, number 6. Come back here, see what number 6 is gonna be, 1, 2, 3, 4, 5, and 6. So you will be connecting your oscilloscope right here. How you will connect it? Again, by just using a simple wire. And the negative, which is the black wire, of your oscilloscope, you will be connecting that with this common ground. All the black wires in the I shouldn't be saying black wires, but it's the negative of all the power supplies and oscilloscope. You should be connecting with the negative common ground right here. One more thing, you might get confused at what about this part, that this is positive 15 and negative 15. What about the two black wires we're gonna get from this side? You will also connect that with this common ground. This is common for everything in the circuit. I really hope it works, and best of luck guys for the final. Let me know if you guys have any questions, and again I apologize to those who were waiting for me to meet them to explain the circuit. um, but this week I'm just being too busy with a lot of different stuff. But if you guys still have any questions, feel free to ask me, and best of luck.